This is a quick presentation of Tentatron Laboratory in-house advanced third-party testing dedicated on any LED driver. Well, here you have a LED tube, can be run in much more powerful LEDs, drivers. The key thing is we have developed an in-house software, advanced software with acquisition module I will explain, and you can change many parameters including the grid system. So very quickly, for example, here in this case you can apply many flickering estimates, and you can see we can measure the total harmonic distortion, the power factor, the input watts, the output watts, and the system efficacy, the lux relative, and so. Very quickly, for example, if I change the voltage, so you see I am turning here the variable. Here I'm about 150 volts, so you can see many parameters. A very quick overview of this in-house test bench software and hardware. Okay, so on the hardware part you've got 6 isolated independent channels, acquisition channels. 3 of them are dedicated to the input grids, and as you know, you can change the voltage grid. You got current probe, voltage probe, and again you get the same thing, except you see in between you will get the LED driver or the LED ballast, and here this is the output which would then be connected to the LED chip. So again, current probe and so on. And you got very fast photodiode with its amplifier, which for example is triggering here, you know. And the key thing is, on the software part, we've got a master and a slave. Each are an ARM Cortex M3 processor, very fast. Each channel is sampling at 100 kHz, 12 bits per sample. And this is much higher than most of the testing done in a laboratory. And the reason is that so far most of the LED driver do have high flicker, and there's no real obligation or really let's say agreement on worldwide level what should be flicker free and many things like that. So this test is ready for, let's say, for the next generation of LED driver, where we target the near zero flicker, deep dimming with high power efficiency, high power factor, low total harmonic distortion, really checking when you move the grid, what are the impact on all these parameters, the inrush. And with such high sampling frequency, you can really, let's say, test classic LED driver, small one, high power, and also the driver on board, things like that, which so far are known to generate a lot of flicker, and also the PWM LED driver. This is an engineering advanced testing lab that can help any manufacturer or supplier. Some companies have already benefited from this type of testing to help them improve their product, to have a third-party testing.